In the first episode of this project, we have conquered the Zen mode by creating efficient algorithm to play this very interesting game, and as mentioned in previous video, today we will be focusing on all the puzzles that creators give us to play around. If you haven't watched the first part, I personally would recommend checking it out first, since some of the stuff said in this video might become unclear. Going back to the video, we need to ask ourselves, how do we start creating this bot? Can we simply open puzzles and run it? Sadly, no. My code was not made with intention to clear puzzles, and PopCap added two new entities only available for puzzle game mode, to which we'll come back later. For now, let's check out the first puzzle. As you can see, this puzzle is really simple and it only requires two moves to be cleared. However, our first approach, made for Zen mode, lacks one very important detail which makes easy puzzles really difficult. If we take a puzzle board and try to solve it, we first need to determine which move is the correct one. To tell which move is good and which isn't, we can simply play the game until we win or lose. Losing would indicate that the last move we did was simply incorrect and should not be repeated. And this is what we want our bot to do. To explain how I did it, let's go through that process step by step. The first step is the same as in the Zen game mode. We check for every possible move on the board and store them. Then we can take one of the moves and execute it. Here comes the part that makes a big difference between these two game modes. In Zen, we look for the best move possible, one at a time. The reason why we were checking the board after the move was to see which move gave the most amount of points, not if it actually clears the board, because it wouldn't be possible. But on puzzles, the main thing we need to focus on are the moves that lead to the victory, so we cannot replicate them in real time. Because think about it that way, assuming that on average, every move takes 2 seconds, if you have a board as simple as this one, you can see that the first board already has 16 moves and you need 12 to solve it. Assuming that we take every single bad move that there is, we can roughly estimate that this process would take about 56,000 years, which is clearly more time than we have. Moving back to our first puzzle now, using some old code we can already tell every move on the board, but we need more than that. Because after choosing a move to do, we also need to clear every match we have created, apply the gravity, and store the move we just did. We want to keep it somewhere, because if the move will turn out to be bad, we can simply go back to the place where the board was still solvable. In this very first puzzle we can already see something that our code cannot handle. Chain of moves. To explain why it's such a big deal, let's see how our code sees the game to understand it better. At first we choose the move we need to do and execute it. Then delete magic gems and apply gravity. Our code doesn't check if after applying gravity, we haven't created any connections we can clear. To do that we would need to call the function as many times as long the chain may be. But there's a trick to avoid that. Welcome our new contender, recursion. If you're not a programmer, you may not know what that means, so let me walk you through it. A function just calls itself if needed, that's all you need to know really. Of course, replicating it was slightly harder than how I just described it, because we need some flags checking if there is a connection on the board. For now this is all that we need. As you can see, this isn't that complex yet, but later on we will have some more interesting gems and this will become more of an issue. Let's give our code a try. After clearing those easy puzzles, we have only one left. However, to access another planet, we only need to clear 4 out of 5 puzzles. For now I'll be skipping this one, but don't worry, I will come back to this as soon as possible. On another planet we are being introduced to our well-known power gems. On the first project there was no need to replicate exactly how power gems would behave, thanks to image recognition. But here we can't rely on it anymore, so we need to put much more details into simulating them. And as it was in the previous episode, this was one of the most problematic parts of this project. Here I just needed to do some minor changes, which simply would tell the bot that it can make connections with the same colored power gems, and puzzle was solved in no time. The bot found really interesting solution for that one. I guess you can say it's not optimal, but I think it makes it look much more cooler. Next puzzle was slightly different, because we need to implement creating power gems. In the case of vertical moves by 4, it wasn't that big of a challenge, because we can simply replace any of the 4 moves with powered one, since it will end up as the lowest one anyway, due to gravity.
complete.
Third planet introduced us with Rainbow Gem, which we know from previous coding that what was as simple as vertical power gems. We simply need to create the Rainbow Gem in the middle of move by 5. On the fifth puzzle, we need to implement something new. Assuming we have a board that looks like this, we can see that technically we can do 2 moves, but both of them will result in the same outcome. Normally that wouldn't be an issue, but if you add one more yellow gem, we can see that one move is moved by 3 and another one is moved by 4, meaning that we need to make some sort of sieving system that will go through every single move and remove some that result in the same outcome. The moves that would be the lowest tier are moves by 3, because they can be overwritten by every complex move. Next would be any moves by 4, and then on the highest tier would be rainbow moves and moves by 5. And with that implementation, our puzzle is ready to be solved. We finally cleared the third planet. So far there weren't any major problems, but don't worry, it will change really soon. Fourth planet introduces one of the 2 mysterious enemies I have mentioned before, being a rock. There isn't much I can say about it. You can't match it with other rocks, so the only way to get rid of it is by using explosions or rainbow gems. And this is honestly how this entire planet looked like.
Puzzles. 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 World complete.
Another planet is pretty big disappointment. The only thing that is being used there is a mechanic that allows you to make moves with open spaces, so there was nothing interesting there.
Puzzles. 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 World complete.
Sixth planet was the one where all our optimizations were put into a test. The first 3 puzzles were rather simple, with the 5th one being even easier. Besides the fact that it took around 1 hour to find a good solution for, the thing that was causing problems was puzzle 4. The first 2 good moves were easy to simulate. The issue was with the third one. Here you have to create a rainbow move with a rock. The problem is that the gravity would create really awkward shape from the gems. It's worth noting that I couldn't find any clear details why this move returns this board, but from what I've tested, it seems to work like this. If gravity will create a gem that is longer than 5, it will try to create a rainbow gem on the left side if the number of the gems is even, and create it in the middle if it's odd. You can see that before gems connect, there's an L-shaped connection. And in this game, no move takes priority over other, meaning that if 2 moves that would result in a different outcome are connected, they both go through. So we have this rainbow gem and this powered one. Trying to figure that behavior out and replicate it well enough for it to work in some other cases, which may occur later, took really long amount of time, but I will never have to come back to it.
Puzzles. World complete. Warp drive ready. Puzzle solved. Puzzle solved.
Moving on to planet 7, we are being introduced with another mysterious entity, and is a bomb. The way it works is simple. There is a number on a bomb that represents how many moves you can do before the bomb explodes. If you do a move when the count is on 0, that means that bomb will explode after your move. Sounds rather simple, but replicating that was pure nightmare. First of all, we need to get a position of the bomb on our board. That turned out to be quite easy, but that was the only easy part in this task. Now we need to somehow get the number that is on the bomb. I didn't want to use image recognition here, so I tried using something else. Number recognition. As it turns out, there are many libraries that can get numbers from even the weirdest handwriting out there. The problem is that our bomb count is not a handwriting, so the library turned out to be quite useless. So I had to come up with something different. After playing around with some more number recognition libraries, I got an idea. What if I would store every bomb number in a folder, and then when I will have a bomb on my board, I will just compare the bomb from the board with every single image I have in my folder. This idea turned out to work perfectly, but just having bombs on the board isn't really what we need to have. We need to implement the countdown system. The way I did it was really lazy, but it turned out surprisingly well. Instead of using really cool bomb emoji to represent bombs, I use numbers instead. And after each move, I simply check the entire board for numbers and subtract 1 from the number. If a number is about to go below 0, we simply explode the bomb. The second part turned out to be really bad to code. Due to some small coding error I made at some point, my bomb count was flawed, and it was flawed in a way that gave me 2 options. Either one of the puzzles didn't work, or the other one. Working around this problem seemed impossible, but after playing around with some other puzzles, I've decided to give it last one try, and somehow the problem fixed itself. And to this day I have no clue where the error was.
Puzzle solved.
Eight Planet decided to settle down with the difficulty, so we're back with normal gems. As easy as those puzzles look like, they were actually quite problematic. The biggest issue I had was with the third planet. Remember the part when I mentioned about keeping track of every powered move we do? This is basically what I meant by that. My initial approach turned out to be quite bad and wasn't keeping track of another move we do, meaning that if I would make a move resulting in 2 power gems being created like here, I would only be able to make 1 power gem instead of 2. Trying to tuck the fix in without doing a lot of logic from ground up made me feel like my code was just about to give up. But as long as I can't see any errors, we are still in the game.
Puzzle solved. Puzzle solved. Puzzle solved. Warp drive ready. World complete.
And that would be the case for almost entire next planet. First 3 puzzles went easy, no shock there. Fourth one had many bugs, which led the bot to think that it found a good solution while it didn't. And the last one had really long computing time. It's worth mentioning that the way how bot determines which move to make, it's not random, but it's simply which move is the first one it found. And which move it is entirely relies on the order in which I code move recognition. So some board could be optimized heavily by simply changing that order. I won't say I haven't used that trick, but I can swear that I haven't abused that. And you can trust me because I'm on the internet, and internet never lies.
Puzzle solved. Puzzle solved. Puzzle solved. Warp drive ready. World complete.
Moving on to planet 10, we can see that there are many more gems than in previous one, but only the 5th planet turned out to create small troubles. Fixing them wasn't really hard, until I realized that the fix I did just happened to break the exact puzzle I didn't want it to break.
But I will never have to come back here.
And the real issue here was actually to create a bug fix that wouldn't break both of those puzzles. So right now, whenever I made any ground change, I had to go through every single puzzle to make sure everything works as intended.
Puzzle solved. Puzzle solved. Puzzle solved. Warp drive ready. World complete.
Going to planet 11, we can see that this one meets us with a mechanic we already know, being the L moves. And as you can expect, entire planet was basically normal puzzle mixed with L-shaped moves.
Puzzle solved. Puzzle solved. Puzzle solved. Warp drive ready. World complete.
We now freely can move into planet 12. Right now our code has no surprises and works just fine. However, one puzzle on this planet was just a copy of a different one, just forcing me to do more moves. Normally that wouldn't be an issue, since if I can solve one, I should be able to solve another one. The problem, however, was how long it took, because those levels took insane amount of computing time, basically suspending the entire project for 2 days.
Puzzle solved. Puzzle solved. Puzzle solved. World complete.
But after being patient for some time, we can finally go to planet 13. This one was really nice looking. We got American flag and some other ones I don't recognize. Puzzle itself was very simple. Our code has been upgraded so many times by now that not much can surprise it, making many remaining puzzles a piece of cake.
Puzzle solved. Puzzle solved. World complete. Puzzle solved. Warp drive ready. Puzzle solved. Puzzle solved. Puzzle solved. Warp drive ready.
But then, the final boss of Bejeweled 2 puzzle, Checkerboard. From what I've heard, every person as a kid was not able to solve that board, myself including. However, knowing the solution, the puzzle only requires 4 moves to be solved. Sounds easy? Wait until you will see those moves. First one is just a normal move by 3, but then the magic happens, and in just one move almost entire board is gone. And now I can happily say that working on the game simulation was definitely worth it, since I didn't even need to edit my code.
However, I should have put more time into optimizing the search, because this one was record-breaking and took almost 80 hours, since the first good move was also one of the last ones. But now it's time for the final attempt, which besides long computing time, wasn't any different than most of the puzzles.
Puzzle solved. Puzzle solved. Puzzle solved. Warp drive. World complete.
And now it's time for the final planet. But first, did you know that the planet layout spells out BGWLD? Well, now you do. And about puzzles in this planet, most of them were rather simple.
Puzzle solved. Puzzle solved. World complete. Puzzle solved. Warp drive ready.
And after solving the 5th puzzle of this planet, there is only one thing we can do. And it's going back to the 4th puzzle in the first planet. After running my code that went through a lot of upgrades, the solution was found in an instant. And now we can finally say puzzle game mode is finally concluded.
Excellent.
So that's it. I know for a fact that I will never play this game again, but I can definitely say it was a fun challenge. The ending credits are kinda long and I don't really have any heartwarming speech prepared, so I think I'll just let the song play and enjoy the moment. By the way, if you enjoyed the video, feel free to leave a like and subscribe. I would highly appreciate some comments too. And of course, thanks you for watching. I'll pretend I didn't see that. See ya!